Alright, so we're going to draw a histogram using this question from paper 62 in winter 2009. This is number 6. It says the following table gives the marks out of 75 in a pure mathematics examination taken by 234 students. Okay, so here's the deal. Basically, we know on pure mathematics exam, because you just took it, that you don't get half marks, you don't get quarter marks, you get whole marks, meaning that the marks that you get are discrete, right? You get 1 mark, you get 2 marks, you get 3 marks, but you never would get 3 1/4 marks. Well, so when we look at this table, it makes sense that you could get, marks 1 through 20, and then it jumps from 21 to 30 because you couldn't get a mark 20.5, right? But when we draw histograms, histograms are continuous, and we have to basically take our data, and even though we would say the marks are discrete, we need to make them a continuous set of data for our histogram. That doesn't mean people are going to be getting different marks. It just means that for our histogram to be connected, we can't have gaps. And what I mean by that is we're going from 1 to 20, but then there's a gap between 20 and 21, right? And you can't have gaps. We go, and then we're from 30, and then there's a gap between 30 and 31. So what we need to do is we need to adjust for the fact that, we can't have gaps. We need to make this continuous. So all we're going to do is we're going to round. So starting here, we're going to round down to 0.5. We always do 0.5s here. And then from 20 to 21, and actually let me just say, you can't have negative marks, right? So we're finding the middle between 0 and 1, which is 0.5. We're finding the middle between 20 and 21, which is 20.5, and so on. Okay, so 40 to 41, the middle is 40.5, or the median, if you will. 50 to 51, it's 50.5. 60 to 61 would be 60.5. And then we know that on the pure math test, there's only 75 marks, but we need to continue on and say, 70 to 75, or 75 to 76 would be, the middle would be 75.5, just so that we are continuing with our pattern here. So the next thing that we need to do is, I'm just going to make a little table here. So, oh, do I want to make a table? Yeah, I'm going to make my mark, like my bins. That's what we call them in the States. My bin width here. I'm just going to list these. And this is how I'm going to create my histogram as well. These are going to be the boundaries on my histogram. And I would say on your Cambridge exams, you want to be as clear as possible about what you're doing. And so you don't necessarily need to make this table, but they need to know that that you're going from 0.5 to 20.5. So you either need to label it extra clear on your graph, or you can make a table so they know, and then still label it on your graph. So the next thing is, and you don't necessarily need to do this on your table, but because all of these look great, except we have this guy from 1 to 20, and this one from 61 to 75, they're different than all the other bins, right? So that means we can't just put the frequency on because our areas wouldn't relate to one another. So what we're going to do now is we're going to look at the width. So how far is it from 0.5 to 20.5? It's 20 wide, right? From 20.5 to 30.5, it's 10 wide. We know all three of these are 10. And then we go from 60.5 to 75.5. Well, that is 15 wide. So basically what we're going to do is we're going to adjust the frequency by the width. So in other words, we're going to adjust the area of our bins, or the rectangles we're going to create for each histogram, based on the width of the bin. So all we're going to do is we're going to take the frequency and we're going to divide it by the bin width. So in this case it's going to be 40, because that's what our frequency is, divided by 20. So the height of this particular bin is going to be 2. Okay, this one, 34, divided by 10 is going to be 3.4. Okay, 56 divided by 10 is 5.6. Okay, my pen is not quite working. 54. Oh, I left a whole column off. Hold on. Let's see if I can insert one here. Probably not. Kind of a big mistake that you wouldn't want to make down the road, so good thing we got that. Okay, sorry about that. 40.5 to 50.5 would be important, otherwise we would be able to do this histogram. Okay, sorry, so 54 divided by 10 equals 5.4. 29 divided by 10 equals 2.9. And then finally, 21 divided by 15 is 1 6/15. Yeah, 1 2/5, which would be 1.4. Okay, so basically, now we're set to make our histogram. This would be and we would want to label these. Oops, we'd want to label these FQ or frequency. Not FQ. FD for frequency density. So I'll write that. So these are the frequency densities. Okay. And these are the numbers we'll be plotting on the y-axis. Okay. And these are the values that we'll be plotting on the x-axis. And these, they don't matter anymore. Well, I mean, they matter. You see them here, but we're not going to do anything with plotting these. So let me go over to my graph. So basically, I am going to how do I do this? Let's see what we have to go to here. We're going all the way up to, our highest one is 5.4. So I'm going to go by ones here. And I'm going to say that this is the FQ, okay, the frequency density in this case. And you may just want to say, yeah, so people that took the, and then these would be the marks down here. And let's see, how many do we have? Okay, so I'm going to go by fives. And then we'll adjust. I'm just going to mark every 10. So here's 10, 20, 30, 40, 50, 60, 70, and 80. Really made it there. Okay, so the reason the table's nice is because when you do this, they know what you're plotting if you don't write it right there. Otherwise, you're going to have to be marking 0.5s all through your graph. So I'm just going to go ahead and start. I'm going from 0.5 to 20.5, and then I'm going up 2 units. So 20.5 is like right here. So I'm just going to kind of draw this in, and then 0.5 would be like here. Okay, and you need to make sure that they know there's a gap there. So there we go. Here's this one. Okay, the next one was 20.5 to 30.5. So remember, these histograms touch, so there shouldn't be a gap. That's why these are the same numbers. And I'm going up to 3.4. So this is like 3.4. So I'm going over to barely past 30. And of course, if I were doing this, say, you know, not on a computer with a stylus, I would make sure that my lines are a little more accurate. It's a little easier to draw these with the pencil. Okay, and I'm just going to continue 30.5 to 40.5, going up to 5.6. Okay, it's just getting crooketer and crooketer, but these should be perfect vertical lines, which mine are not, so hopefully yours will look a little better. We're going up to 5.4 on the next one. 5.4, right about here. Okay, 5.4, almost to the end. Then we're going up to 2.9. Okay, so 2.9, and we're still at a bin width of 10. So this is 60.5. Okay, and then finally, our very last one, we had a height of 1.4, frequency density of 1.4, and it went to 75.5. So if we didn't do this, what would happen with our histogram is it would look really uneven. Because there's a wider span, we need to take into consideration that more or less data may fall, but it's not necessarily comparable to the narrower bins if we don't adjust for the fact that the area is actually a different space. So, I guess finally we should give this a title. We might want to say pure math marks. And though Cambridge doesn't require it, I would say n equals 234, just because when I look at data, I like to know what my n is. So that is part I for that one.